Okay. We'll go over the 17 multiple choice together, and then you guys can do the problems on your end. The problems for this are pretty easy. They're going to be easier than what's actually on your test. So I would focus more on the group quiz for what the problems are going to be like on the test. Alright. We've done some of these before, but I just picked them randomly. So, which of the following is not an example of simple harmonic motion?
Ball bouncing on the floor.
Ball bouncing on the floor. Why is it a ball bouncing on the floor? Brian.
Because when it hits, it doesn't go up to the same height.
It doesn't take the same amount of time to go back and forth each time.
Yeah.
Okay, a mass spring system can oscillate with simple harmonic motion because a compressed or stretched spring has what kind of energy?
Delta.
Elastic potential, so D.
Sounds fun.
By what factor should the length of a simple pendulum be changed in order to triple the period of vibration?
Charlie.
Okay, so for a mass in a spring, it's T equal, or a mass in a pendulum, it's T equals 2 pi times the square root of L over G. How many times do we have to increase L to get T to be 3 times what it was?
9.
9. Why 9, Michael?
Square root.
The square root. So it's going to increase by the square root of however many times you increase L. Does that make sense, everybody? So if you wanted to double the period, how many times do you need to make L bigger?
4 times.
4 times. Does that make sense? What if you wanted T 4 times bigger? 16.
So what's the answer?
Answer is C. Okay. Which of the following most affects the wavelength of a mechanical wave moving through a medium? Assume that the frequency remains constant.
Nature of the medium.
Nature of the medium, because nature of the medium affects what? The speed. So when the speed changes, if the frequency stays the same, the wavelength will change.
What's the answer?
It's A, nature of the medium. Alright, number 5. When two mechanical waves coincide, it means they meet. The amplitude of the resultant wave is always blank the amplitudes of each wave alone. Well, those two answers depend on whether they're both up or both down. It's just saying they're meeting. The sum of. So the answer to that one is C. So if they're one's up, one's down, then one would be negative, one would be positive, and you subtract them. Does that make sense, everybody?
Yeah.
Okay, number 6. Two mechanical waves meet and coincide. One has a positive displacement from equilibrium, the other wave has a negative displacement. What kind of interference occurs?
A. Speed.
B, destructive interference. When they cancel out, it's destructive. When they make each other larger, it's constructive. So if they're on opposite sides, they're going to cancel out. So it's going to be destructive interference.
Is there such thing as complete constructive?
No, there's complete destructive if they like totally cancel out and it's just there's no wave left. Alright, this is that one that we didn't make any sense before. I'm going to do it though because it's a good problem, even though the wording doesn't make any sense. Okay, so we have, what is it, a wave that is read the question again here. A 3 meter long stretched string is fixed at both ends. If a standing wave with wavelengths 2/3 of the length, so 2/3 of 3, are produced in the string, how many nodes will be formed? Alright, so it's a total of 3, and one wavelength is 2/3 of 3. So if it's 2/3 of 3, how long is that? 2. So how many more wavelengths will we get in there? One wavelength is 2. Half. So the total thing is going to look like that. Does that make sense to everybody? So it says one wavelength is 2. So it's 2 from there to there. So we have another half wavelength to get to 3. Now how many nodes are there? 4. 1, 2, 3, 4. Ellie?
Wait, never mind.
Any questions about that one? Alright. Number 8. At a distance of 3 meters, the intensity of a sound will be blank the intensity of a distance at 1 meter. It's going to get louder or softer first off. Softer, so it's going to be A or B. And it's an inverse square law for how loud sound is. So A. So 1/9. So it's the intensity of the sound decreases as 1 over the distance squared. Does that make sense, everybody? So if, let's say at 4 meters, how much softer would it be? 1/16. 1 over the distance squared. Okay. 2 easy beat questions here. How many beats per second are heard when 2 tuning forks have frequencies of 342 and 345 hertz are held side by side? 3 hertz.
Alright.
Just the difference between the two. Same deal for the next one, 216 and 224.
8.
8, so B. Number 11, noise canceling earphones are an example of B, destructive interference. Alright, this is what you're going to have to remember from the notes. The phenomenon of beats results from sound
C. It's always all the above.
interference.
The one
So
none of us guessed.
You have 2 waves that are alternating between constructive interference and destructive interference when you have beats. Longitudinal wave lacks which of the following properties? Remember, longitudinal is when it goes like this instead of like this. What's this one called?
I'm going E.
Transverse.
Transverse.
This is longitudinal. This is transverse.
What's longitudinal?
This.
It's E though.
It is E. That is correct, Brian. Longitudinal wave has all those things. The one that you might think it is would be amplitude, since it's going like this. But the amplitude is how much is compressed or how much it's stretched out. Does that make sense? So it's E. It has all those things. Number 14, as the sound of a car's horn passes and recedes from you, the pitch of the horn seems to decrease. Right, number 15, the Doppler effect is the change in observed frequency due to C, the motion of the source or the observer. Number 16, a sonic boom. A is swept continuously behind the plane. The one key thing about this one is that it doesn't just happen when it breaks the sound barrier, it constantly happens after it breaks the sound barrier. Number 17. A leaf on a pond oscillates up and down 2 complete cycles each second as the water wave passes. What is the wave's frequency? C, 2 hertz. Key thing here, guys, frequency is cycles per second, so we have 2 cycles per 1 second, so it's 2. Period is seconds per cycle. So the period would be 0.5 in this case, but we're asking for the frequency. Alright, any questions on any of those? Alright, do you want me to read off the answers to the 4 problems there, or 5 problems?
Absolutely.
Alright, number 18 is 280 newtons per meter. 19 is 0.0575 hertz. 20 is 316 meters per second.
16 or 16?
316 meters per second for number 20. Number 21 is 464 hertz. 22 is 1 hertz. Like I said, guys, these are probably a little easier than they should have been. These are some of the easier questions, so look more at your group quiz and that kind of stuff. What? 464 for number.
Do either of you guys want the group?
So, is it